Hello student, welcome to our third lesson on liquid-liquid mixtures. There are two types of liquid-liquid mixtures, namely immiscible liquids and miscible liquids. Immiscible liquids, these are liquids that do not mix but form distinct layers. Examples of such liquids mixtures are vegetable oil and water, kerosene and water. So the two form distinct layers, they do not mix. While miscible liquids, they are liquids that mix to form homogeneous mixtures. So there is uniform distribution of the molecules of the liquids. Examples are water and ethanol mixture. Then we have water and milk mixture. Separating immiscible liquids. To separate kerosene from a mixture of water and kerosene, sometimes called paraffin. For ease of identification, a water-soluble color is added to the mixture and mixed well. The mixture is then transferred into a separating funnel. It is allowed to stand for a while. The separating funnel look like that. We have the stopper, we have the separating funnel, then we have a tap here. So remove the stopper, this one, and open the tap of the separating funnel and allow the bottom layer to flow into a beaker. Why do you remove the stopper? So that the liquid can flow. So it allows the atmospheric pressure to be in here so that the liquid can flow. Discard the interface, leaving the top layer in the separating funnel. So the interface is this part. We continue. Note, interface is a boundary between water and kerosene. Observation and discussion. A mixture of water and kerosene is immiscible. They do not mix. The water is colored to distinguish it from kerosene or paraffin. Kerosene is less dense, that is, it is lighter than water, hence it floats on water. The interface contains both water and kerosene. It is discarded because it is not easy to separate the two liquids at the interface. So this part is discarded. Immiscible liquids are separated by using a separating funnel. Decantation can also be used to separate immiscible liquids, but it is not efficient. So we have decantation here. We have the water which is down because it is denser than the paraffin. Then we have this process of decantation where you allow the paraffin to flow out first, and then you are left with water in the beaker. A dropper can also be used to separate immiscible liquids by sucking the upper layer. The dropper is used to suck one layer, transferring to another beaker repeatedly. So the one that is being sucked by the dropper is the lighter liquid or the less dense liquid. In this case, paraffin is less dense, so it is sucked and transferred to another beaker. So this is also not an efficient method of separating immiscible liquids. Now let us look at separating miscible liquids. To separate mixture of water and ethanol. These two liquids form homogeneous solution or maybe homogeneous component. A mixture of ethanol and water is placed in a round bottomed flask as shown below. So we have the round bottom flask, and it is usually preferred when you are heating because the round allows the uniform distribution of heat. Most of the time when you are heating a substance, we use a round bottomed flask to allow uniform distribution of heat. We have the wire gauge, and then we have the tripod stand. We have the mixture of ethanol and water. Then we have the fractionating column, and then we have the beads. We have the thermometer there. Then we have the Liebig condenser, where we have the inlet down here and the outlet up there. Then we have the beaker. Also you can use a conical flask. So the mixture is heated gently and temperature changes are noted. That is why you have the thermometer. The distillate is collected in the beaker or a conical flask. So we have the distillate here, the condensed liquid, because it escapes here as a vapor. Then at this point it is a liquid, and it's the one referred as distillate. Transfer a little distillate on a wash glass and write it. Observation and discussion. Water and ethanol are miscible liquids. They are separated because they have different boiling points. So we apply the boiling points when we have miscible liquids. Pure ethanol boils at 78.2 degrees Celsius, while pure water boils at 100 degrees Celsius at the sea level. When a mixture is heated, ethanol boils off fast at 78 degrees Celsius and is collected as the first fraction of the mixture because it boils fast. The temperature remains fairly constant until ethanol distills off. At this stage, the temperature starts rising and the distillate collected thereafter is mineral water as the second fraction. This process of separation is called fractional distillation. The purpose of fractionating column is to allow water vapor to condense into liquid and flow back into the round bottomed flask before the boiling point of water is reached. So that's the function of the fractionating column, the one with the beads. The glass beads increase the surface area for water vapor to condense. Fractional distillation is used to separate miscible liquids that have different but close boiling points. A Liebig condenser uses the counterflow principle to cool the vapor efficiently. The counterflow, which is vapor flows in one direction to the cooling water. So there is an opposite movement of the vapor and the cooling water. So we have the vapor here going that way while the cold water moving this way. So there is that movement. Application: distillation of crude oil to obtain fractions such as diesel, petroleum, cooking gas are some of the application of fractional distillation. Then we have recycling of used oil. This is happening at Athi River and Kikuyu town. Then we have liquid air in manufacture of nitrogen and oxygen, like we have in British Oxygen Company, BOC. Then extracting oil from nuts and seeds. This is a process known as solvent extraction. So how do you do this? Crush groundnuts, seeds in a mortar using a pestle. Continue crushing the nuts while adding propanol a little at a time. Decant the resulting solution into an evaporating basin or dish. Leave the solution in the sun for some time. Put a drop of residue liquid on a piece of paper and hold the paper against light. Cashew nuts, coconuts, castor oil seeds, sunflower seeds, and cotton seed may also be used instead of groundnuts. Observation and discussion on solvent extraction. The oils from these nuts and seeds are extracted using a solvent such as propanol. The nuts are first crushed to increase the surface area in contact with the solvent. And the solvent here is propanol. As soon as the oil has dissolved in the propanol, the solution is left in the sun for solvent to evaporate. The oil has a higher boiling point compared to the solvent. Therefore, oil is left in the evaporating dish. This method of extraction is known as solvent extraction. Solvent extraction is also known as liquid-liquid extraction, separated due to their unequal solubilities in the solvent. When placed on a paper, the oil leaves a translucent patch on paper, a simple test for presence of oils. Further purification can be done by washing the product in water and separate water from oils using a separating funnel like we did earlier. Application: extraction of oils from nuts and seeds, then natural dyes from plants, some herbal benison from plants, caffeine from tea and coffee. 2. It can be applied in dry cleaning to remove dirt. Here is assignment on liquid-liquid extraction. There are all these questions. Ensure you get the correct answer. Train your brain to remember all the concepts. Thank you and wish you success.